So this first one says the number of bacteria grown in a lab can be modeled by P of t equals 300 times 2 to the 4t, where t is the number of hours. Which expression is equivalent to pt? All right, so basically, how can we simplify this?
16.
Okay, so it had to be 2 to the 4th power, right?
Yeah.
Which is 16.
Yeah.
So we simplify it that way. All right, so for number 2, during physical education class, for the exercise times in minutes, heart rates and beats per minute for his classmates, which table represents a linear model of exercise. All right, so with linear, the first thing we should be thinking is slope. Okay, so we want the same growth from one point to the next. So this left column is 1 through 4 on all of them. So we just got to make sure. So we went up 5, 5.
Oh, okay. So it's 1.
So it should be this one, but look, just check these ones just to make sure. Here it went up 7. Here it went up 5. Here it went up 5. Here it went up 4. Here we went 8, 13, 5, and 2. Here we got 3, 1, 7, and 2. So yeah, it's linear because for every minute exercise, the heart rate went up 5 beats per minute. All right. Why it jumps to number 10, but all right. So on number 10, Gretchen has $50 that she can spend at the fair. Ride tickets cost $1.25. Each game ticket costs $2. She wants to go on a minimum of 10 rides and play at least 12 games. So that's.
Wait.
Well, we can figure out the equation.
Does it skip to question 10?
Yeah. Yeah, we threw these together that last day, so we don't really have much time to go through there. All right, so if it's going to be, we'll let R equal ride. I'll let G stand for games. Okay. So you can either do this equation, you can let's set the equation first, because that will probably tell us the answer. So it's $100.25 per ride. So you got 125 times R.
Oh, all right.
Plus $2 per game. So that doesn't help us because that's the equation for all of them.
Yeah.
She has $50 she can spend. So can she has to spend less than $50, right? She can't spend more, so it has to look like this. And it's okay if she spends 50, as long as she does not go over 50. So that's how our equation has to look. So that'll eliminate those two answers. Right, and then you got to look at the inequalities here. So we got to look at these. So she wants to go on a minimum of 10 rides. Okay. So that's less than or greater than or equal to 10 on both sides. So that doesn't change. So we got to look at games. At least 12 games. So it has to include 12. So it has to be 2. She wants to go on a minimum of 10 rides and at least 12 games. They both have to have the equal to underneath.
Okay.
All right, so number 11, 3 functions. So these are 3 different functions here. Okay, you have f of x, g of x, and h of x. They want to know what statement is true. Y-intercept, y-intercept. So it looks like they're comparing all y-intercepts. So right here, see, my y-intercept is 1. Here, I can see my y-intercept is -1. Now, to find my y-intercept here, I have to plug in x equals 0. So when I do that, 3 to the 0 power plus 2, this gives me 1 plus 2, which gives me 3. So these are the 3 things they want us to look at. So, all right, so we just got to figure out which they say. So the y-intercept of h of x is greater than f of x. That's not true.
Not true.
Cross that out. Y-intercept of f of x is greater than g of x. That's one's not greater than 3, so that's not true. Y-intercept of h of x is greater than both. No, that's the lowest one. That's the highest one, so it has to be this one.
Yeah.
The y-intercept of g of x is greater than both of them. Yeah, 3 is the biggest one, so it's 4. Um, 13, if y is this and z is this, which polynomial is equivalent to 2? So all this is a substitution. So this is y, this is y, this is z, this is z. So you just plug them in. So I got 2 out front, and I'm doing y, so I have 3x cubed plus x squared minus 5. And then I'm adding, plus z, so plus x squared minus 12. Remember, it's plus, so that means we can just combine like terms. There's only one cubed, so I got 3x cubed. I can combine my x squared, so that gives me 2x squared, and then combine my constants, gives me -17. Now you also have the 2 out front here still. So you have to distribute that. So this gives me 6x cubed. This gives me 4x squared, and this gives me -34. So that's going to be 1. All right, so on 16, you can either factor this, or we can use quadratic formula. Usually with a being greater than 1, we're going to use quadratic formula. So a equals 2, b equals 1, c equals -3. So the quadratic formula is x equals opposite of b plus or minus radical b squared minus 4ac over 2a.
Okay.
So we go through and do that one then. B is 1, so it's going to be -1 plus or minus 1 squared minus 4 times 2 times -3 over 2 times a, which is 2. So to clean all this up, this gives us 8, 24, plus 24. So we get -1 plus or minus radical 25 over 4. We know that radical 25 is 5, so we get -1 plus 5 over 4 and -1 minus 5 over 4. So this gives us 4 over 4, which is 1. And this gives us -6 over 4, which is -3/2. So those are our 2 answers. Now, so on this one, we cross these off. These aren't even factored correctly. So it's between these right here. So remember, if this is +1, right, it's going to have to be x minus 1, so it's going to have to be 2. So remember when you solve these, x minus 1 equals 0, you add 1.
Yeah.
Find out x equals 1. The same thing here, you would 2x plus 3, subtract 3, and then we get -3/2. So that's where these 2 answers come from. All right, 17. Each day, a dog shelter spends an average of $2.40 on food per dog. The manager estimates the shelter's daily expenses, assuming that there is at least one dog in the shelter using the function below. Which statement regarding the function are correct? Which statements are correct? All right, so what does X represent? Is that going to be the number of dogs or the number of volunteers? Well, so you look up here, if this is $2.40 per dog, that means X has to be.
The number of dogs.
So it has to be that one.
Per day.
So just knowing that that's there, you can cross off both these answers so they don't include one. We know it's not 2 also because we just said it's dogs, not people.
It's not 4, right?
30 represents total expenses per day. Well, remember, E of X is going to be the total expenses. So 30 is going to be the non-food expenses. So it's going to be 4. What that means is even if there's not any dogs in the shelter, it's going to cost them $30 a day to open the place, whether it's electricity, whatever it could be. Those are just the expenses other than food. So it's going to be what? This one here then, number 2?
Yep.
So then for 18, which point is not A in the solution set of the equations below? So this is basically just a substitution problem. We can move this equation around if we wanted to. Okay, but all you're gonna do is all these answers have an X and a Y. You're just gonna plug them in and see which one works. So the easiest way is in the calculator. So say if I do number 1, 3 times Y, so that's 3 times 10 plus 2. Gives me 32. And then on the right side now, I plug in my -2. So I have -2 squared minus 5 times -2 plus 17. So see how the left side gave me 32, the right side gave me 31. So that tells me that's not a solution.
Yeah, okay.
So 1's going to be our answer. Now we'll check one of these other ones just to make sure. Let's look at number 3 here. So if I do 3 times Y, which is 3, plus 2, I get 11. Now on the right side, I'm going to plug in 2 here. So I got 2 squared minus 5 times 2 plus 17. And then 11 and 11, they match. So that tells us that is a solution. And you can check 2 and 3, and it'll give you the same thing. The left side will match the right side. Which of 3 statements, 3 situations given below is best modeled by an exponential function? Okay, so what's that?
I'm just doing it.
So which one do you think it is?
Hold on. Number 4 is not right. We did it by 4.
This is like the assignment we did at the beginning where it was linear or exponential.
Yeah, I remember. I think it's 3, but.
Okay, so just look at these situations here. The one we definitely can cross off is the second one here. If it grows 4 inches every day, that means you're going, that's a linear function. Which one do you think it was? 3? You decline by 5%. Okay, that's definitely one of them. So it's definitely 3. But so that crosses off, right? So that means it has to be 1 also, which if something doubles every day, just think about it like the number 10. Okay. If I double that, it's 20. If I double that, it's 40. I double that, it's 80. So that is exponential growth. All right, and then the last one here, 24. The length, width, and height of a rectangular box are represented by the following below. When the volume is expressed as a polynomial in standard form, what is the coefficient of the second term? So this is a lot with this problem. First thing we have to do is figure out the volume. Then we have to put it in standard form, and then we need the second term. All right, so what's the volume of a box? It's length times width times height. So all that means is you're going to multiply all three of these terms here together. All right, so we got 2x. You have 3x plus 1, 5x minus 6. And I'm going to go ahead and do this one first just because they're next to each other. So distribute. 2x times 3x is 6x squared. 2x times 1 is 2x. Now here I have to FOIL, I have to distribute. So I'm going to do 6x squared times 5x, which gives me 30x cubed. I'm going to distribute here 6x squared times negative 6, which is negative 36x squared. And I have my inside terms. 2x times 5x is 10x squared. And 2x times negative 6 is negative 12x. Combine like terms right here. I have 30x cubed minus 26x squared minus 12x. All right, so that's my volume. Now I got to check, make sure it's in standard form. It is because it goes 3, 2, 1 with my variables. Coefficient of my second term. So again, we need to know coefficient also. This is my second term. My coefficient is the number in front, so it's negative 26. So that's a really complex problem, but that problem can test you on 3 or 4 different standards. So that's what kind of problems you're going to see sometimes.